Welcome back to Fact Bloom Insights. Rivers are often seen as symbols of constancy, flowing resolutely from their sources toward the sea. Yet, beneath this seemingly unchanging surface, rivers can sometimes defy expectations, running in reverse, flowing upstream against their natural course. This fascinating phenomenon, while rare, is driven by a complex interplay of natural forces and human intervention, each with its own dramatic consequences. Understanding why some rivers run backwards not only deepens our appreciation of the planet's dynamic systems, but also highlights the environmental and societal impacts that such reversals can have. One of the most common reasons for rivers to flow backward is the influence of tides. In regions where rivers meet the ocean, tidal forces can temporarily overpower the river's usual downstream flow, causing the water to surge upstream. The Qiantang River in China offers a spectacular example of this. Every year, it is home to the world's most powerful tidal bore, known as the Silver Dragon. During certain tides, waves as high as 9 meters rush inland, reversing the river's flow for several kilometers. This phenomenon draws thousands of spectators who gather to witness the raw power of nature as seawater pushes against the river's current, creating a dramatic reversal that can last for hours. The Thames River in England also experiences tidal influences, though on a smaller scale. During high spring tides, the lower reaches of the Thames can temporarily reverse, with seawater pushing upstream into the heart of London. Similarly, the Amazon River in South America, one of the world's largest rivers, experiences a tidal bore called the Pororoca. Twice a year, massive waves surge upriver for dozens of kilometers, disrupting river traffic and reshaping the landscape as the Atlantic tide invades the Amazon basin. These tidal phenomena demonstrate how the gravitational pull of the moon and the sun on ocean waters can extend far inland, causing rivers to run backward with surprising force. Extreme weather events, particularly hurricanes and tropical storms, can also induce river reversals. In August 2012, Hurricane Isaac battered the southern United States, bringing not only wind and rain, but also a dramatic storm surge that reversed the flow of the mighty Mississippi River. For nearly 24 hours, the Mississippi's current was pushed upstream as ocean water surged inland, defying the river's natural direction. The U.S. Geological Survey reported that the river's flow rate reversed from its usual 1.5 million gallons per second downstream to a 1.5 million gallon per second upstream surge during the height of the storm. A similar event occurred in 2005 when Hurricane Katrina's powerful winds and rising sea levels overwhelmed the Mississippi, briefly turning its flow back toward its source. These reversals are not only dramatic, but can be catastrophic, overwhelming flood defenses, inundating communities, and altering the river's ecosystem. Geological activity offers another pathway for rivers to run backward. Earthquakes, landslides, and shifts in the Earth's crust can abruptly change a river's course, sometimes causing it to flow in the opposite direction. The Kosi River in India is a potent example. In 2008, unprecedented monsoon rains triggered a massive breach in the river's embankment. Within days, the Kosi shifted its channel by over 100 kilometers, inundating vast areas of farmland and displacing more than 3 million people. Satellite images revealed the river's dramatic change, as it carved a new path across the landscape, temporarily reversing its flow in some sections. Such geological upheavals can have long-lasting consequences, reshaping entire regions and altering ecosystems that depend on the river's original course. Human engineering has also played a role in reversing the flow of rivers, sometimes permanently. The Chicago River in the United States is perhaps the most famous example of this. At the turn of the 20th century, Chicago faced a dire public health crisis. Sewage and industrial pollution were contaminating the city's drinking water, flowing from the river into Lake Michigan. To address this, engineers undertook a massive project to reverse the river's flow. In 1900, they completed the Chicago Sanitary and Ship Canal, which redirected the river's waters away from Lake Michigan and toward the Mississippi River basin. This engineering feat, hailed as one of the greatest of its era, permanently changed the direction of the Chicago River, safeguarding the city's water supply but also setting off decades of ecological adjustments downstream. The impacts of river reversals, whether temporary or permanent, can be profound. When tidal bores surge upstream, they erode riverbanks, disrupt navigation, and reshape habitats for fish and birds. During extreme weather events, reversed flows can overwhelm flood defenses, inundating cities and farmland, and leaving lasting scars on the landscape. Geological changes, like those seen with the Cosi River, can displace millions of people and transform entire regions overnight. Even human-engineered reversals, such as the Chicago River, create new challenges for water management and ecological balance, as altered flow patterns affect everything from water quality to wildlife migration. Recent research underscores the importance of understanding these phenomena. Scientists have used satellite imagery and advanced modeling to track river changes over decades, revealing that sudden reversals and course changes are more common than previously thought. For example, a comprehensive analysis of river dynamics over 50 years identified dozens of instances where rivers abruptly shifted course, sometimes running backwards as a result of floods, earthquakes, or human intervention. These studies highlight the need for vigilant monitoring and adaptive management, especially as climate change increases the frequency and intensity of extreme weather events. In regions prone to tidal bores, communities have adapted by building flood defenses and altering infrastructure to cope with the regular surge of seawater. In places like Chicago, ongoing investments in water treatment and ecological restoration aim to balance human needs with the health of the river ecosystem. Meanwhile, after the Cosi River's dramatic shift, efforts to rebuild homes, restore farmland, and strengthen embankments continue, illustrating the resilience and adaptability required when nature redraws the map. Rivers that run backward are more than rare curiosities. They serve as powerful reminders of the dynamic forces shaping our planet. Whether driven by the pull of the tides, the fury of a hurricane, the shifting of the earth, or the ingenuity of human engineering, these reversals challenge our assumptions and demand new solutions. By studying their causes and consequences, we not only gain insight into the natural world, but also prepare ourselves to respond to the challenges and opportunities they present. As climate patterns shift and human impacts grow, the story of rivers running backward will continue to evolve, reflecting the ongoing dance between nature's power and human ambition. Don't forget to like, subscribe, and share to follow the next videos.